So, welcome back to the lecture series of communication system. In this lecture, I am going to discuss about the pulse modulation. So, Nyquist so that it is possible to reconstruct a band limited signal from a periodic sample as long as the sampling rate is at least twice the frequency of the highest frequency component of the signal. So it means we are able to reconstruct a signal if the rate of sampling is at least twice of the maximum frequency component present in the signal. Several types of sampling are available for pulse modulation. See this particular diagram here. The sample follow the signal level. In the second case, sample remain at the signal level. Both can be used. Either the sample follows signal level or the sample remains at the signal level at start of the signal. So these are the basically method of the sampling. So the pulse modulation, digital transmission of analog signal, sampling theorem and application. So these are the basically topic I am going to cover in this topic. So first we discuss what are the pulse modulation, how the pulse modulation is divided. So it is divided actually in the two parts: analog pulse modulation and digital pulse modulation. Analog pulse modulation, there are pulse amplitude modulation, pulse time modulation. So this particular pulse time modulation is divided the pulse width modulation and pulse position modulation, and the digital pulse modulation is divided in the pulse code modulation, delta modulation and adaptive delta modulation. So in this lecture we are going to discuss about the pulse amplitude modulation and pulse position and pulse width modulation. So here, see here, the first signal is a modulating signal, and these are the carrier signal, and it is the carrier for the pulse modulation. So see here, the carrier used for the continuous signal is also sinusoidal in nature, but the carrier used in the case of the pulse modulation system are a square waveform or the pulse train. Comparing to the continuous wave modulation, the performance of all pulse modulation scheme except PAM in presence of noise is very good. In the case of the pulse amplitude modulation, noise immunity is very poor. Due to better noise performance, it requires less power to cover large area of the communication. These are the basically region we are moving from the continuous modulation to the pulse modulation. Due to better noise performance and requirement of less signal power, the pulse modulation is most preferred for a communication between spaceship and Earth, because here interference is large in that type of the communication system. Then we start the first topic, that is called the pulse amplitude modulation. Then the definition of the pulse amplitude modulation is the pulse in the amplitude of the pulsed carrier varies in accordance with the instantaneous value of the modulating signal. Is called pulse amplitude modulation, where width and position remains constant. It means amplitude of the pulsed carrier is varied in accordance with the instantaneous value of the modulating signal. So it means in the comparison to the AM, if you see the definition of the PAM, where we use the term pulse carrier. Then see this particular diagram. A modulating signal is first passed through the low pass filter, so that we have fixed its maximum frequency component. Then it's simple pass through the multiplier, and input of the multiplier, there are the two input of the multiplier. In one input we passes a modulating signal after the low pass filter, and the second input of the multiplexer is connected to a pulse generator. It generate a carrier signal, and multiplexer multiply both the signal, and this a multiplied output is shown in the diagram. So see here particular diagram, it is a pulse amplitude modulated signal. Then if this particular slide just show the block diagram of the pulse amplitude modulation. Here we see the actual circuit that is used for the pulse modulated circuit. Then this circuit we are using the two op-amp and one field effect transistor. The gate of this field effect transistor is connected to a pulse signal. So when the FET is on, see this pulse input here, this open, it means this particular gate is open, and when at this terminal gate is short, it means this field effect transistor is on or off depending upon the pulse signal. Op-amp 1 is it is a non-inverting amplifier. So, and if it is a non-inverting amplifier, so it's isolated the analog input channel from the switching function. It means this switching is independent of the input. So it is a simple a non-inverting amplifier, and output of this is passes through this particular switch. So this particular switch convert it into the pulsating, and this similarly if you see the op-amp 2 is just a voltage follower, so it's provide the shape of the output, and also it's increase the voltage. So it's provide some it provide the output that follow the input of this, but it's have the gain is slightly higher to just provide a matching. That it means in technical term we get the voltage follower capable of driving low impedance load. The resistor are used to limit the output current of op-amp amplifier. This particular resistance that we limit the current. So see here, there is a open operational amplifier that work in a non-inverting configuration. It means this particular input is passes to this. So it is a non-inverting, so it is just pass this open without any change, then it passes through the switch. So when this particular field effect transistor is on, then this particular the circuit is grounded through this particular field effect transistor, and when it is the off, then this output of the op-amp 1 is passes through the op-amp 2. That's why we got a pulsating type of output, because when this particular switch is on, then this whole circuit is grounded through this, because it's if the switch is on, it provides a short circuit. So it means then no voltage is passes through this operational amplifier when the switch is on. So in theoretically we call it a multiplier circuit, because in this interval this op-amp is grounded, sorry, its field effect transistor is grounded, so there is no output. So then only output in this duration, then this duration, then this duration, and this duration. It means overall we got a pulsating type of output that is called the pulse amplitude modulation output, because the amplitude is defined, it depends upon on and off time of this particular switch. So this particular circuit is used for the generation of pulse amplitude signal. Op-amp 2 is high input impedance, it is a voltage follower. Basically R is used for the limiting circuit. The most common technique for sampling of wires in PCM system is to sample and hold circuit. The second type of the circuit that is used is sample and hold circuit. See this particular diagram, it has the sample and hold circuit. If you see, compare it to the previous circuit, only we use this type configuration. Here it is a voltage follower, it is a non-inverting amplifier, but here we use a field effect transistor in combination with a capacitance. And what is the advantage of this? See this particular top, it is a flat. See this particular top, it is a flat. So it is a, here we got a flat top sampled output. That's why it is called a flat top sampling. It means this PAM signal having the flat top. In this particular circuit, here the top is depend upon the amplitude variation of the input signal or information signal that decide the top of the pulses. But here, due to use of this particular combination, top of the output is flat. That why this particular circuit is called sample and hold circuit. This switch is for the sampling and this capacitor is holding the output to that particular level till next cycle is start. For here, at this particular point of the time, this capacitor is the charge, and when this capacitor is grounded, then this voltage is maintained. This capacitor, this voltage is maintained. Again this particular switch is off and it is again this particular switch is on and this circuit is connected to this, then again charging will perform. Similarly, at this point of the time, this circuit switch is off, and when this is off, this capacitor does not got a reverse path to discharge. It means this particular voltage is again maintained to this level. Again at this point, this switch is again on, then it's again charged. It means discharge path is not available for this capacitor. That's why it's hold the voltage, hold the whatever this capacitor is charged. That why it is called sample and hold circuit. It means this particular combination is work as a sample and hold circuit, and that output is again called a pulse amplitude modulated output, but here it have a flat top. In the previous case, we got a natural top. That it means the top of the pulse is depends upon the information signal. Here it is not depend upon the information signal. With the help of sample and hold circuit, see this particular here, this FET configuration is different. Gate is connected to this particular pulsating input. Here we see that again here the gate is connected, but to the pulsating, but this particular switch is rotated. It means drain is source is connected to this particular circuit. So this particular combination is work as a sample and hold circuit. Then these are the basically representation of the signal. If signal is this, then we call the unipolar because it's in a one plane. If it is the both plane, then it is called the bipolar. Then again it is the waveform representation of the modulation signal. So C is our information, that is called the modulation. Then our the carrier signal, it is here in this PA case of the pulse modulation, it is called the pulse carrier. Then if we want the output having double polarity, then we got output like this. If we want output with the single polarity, then we got output like this. And the circuitry used for the generation of this type of the signal is different in the both the cases. That's why it is called a bipolar and single polar. Then we move to the demodulation of the pulse amplitude signal. So here we already study about the modulation or how to generate pulse amplitude modulated signal. So generally we use a inverting amplifier, then a voltage follower in combination of a field effect transistor if we require a natural sampling. But if we require a flat type of the output, then we replace this field effect transistor with a sample and hold circuit. Similarly, in the case of the reconstruction, demodulation, we pass the PAM signal to a reconstruction filter, and then it is the equalizer. Then output of the equalizer is a message signal. So see here, it is a mathematical expression is given. In that case, the reconstruction and equalizer, if we represented as a transfer function, then it is represented as the ht. So basically, and in frequency domain, this ht is represented as the hf. So hf is t sinc function of ft, and it is the multiplied by exponential of j pi ft. So basically, sinc function is deal with the amplitude distortion, and exponential function is provide a delay, and the equalizer response is like 1 upon ht, because ht is the transfer function of our modulating signal, and 1 upon ht is the transfer function of our equalizer. So after passing through the equalizer, we are able to generate our actual message signal. So this is all about the demodulation of the pulse amplitude modulation. Then what are the advantage? First advantage of the pulse amplitude modulation, it is easy to generate and we are easily demodulate the pulse amplitude modulated output. And the disadvantage, PAM does not utilize constant amplitude pulse. Output is distorted due to additive noise so that it is infrequently used. It means actually here our information is stored in the amplitude, and noise signal easily alter the amplitude of a signal. It means our information will distorted. And second is transmission bandwidth required is too large, and the third disadvantage is transmitted power is not constant. And what is the use of this PAM is in radio telemetry, especially for the remote monitoring and sensing application. We can use pulse amplitude modulation. So that is all about the today class. Here we discuss about the pulse amplitude modulation, what is the flat top sampling, what is the natural sampling, then what are the modulator circuit we use for the generation of the PAM signal, what are the demodulate, how to demodulate the PAM signal, what are the advantage of PAM, what is the disadvantage and application of the PAM signal. That's all about the today lecture. In the next class we discuss about pulse time modulation. Thanks for your attention.